Alright, for electrolysis of some aqueous solution, because there will be more than one cation and more than one anion, so we have to define which ion will preferentially discharge. And we have learned that the first reason we have to consider about the ECS, which is this one, right? For the cation, the lower one will preferentially discharge. For anion, the upper one will preferentially discharge. And then now I will talk about two more factors which will affect the electrolysis of aqueous solution. The first one, we have talked about it a bit, which is besides ECS, we also need to consider about the concentration of ion. For example, sodium chloride solution will contain two anions, which is hydroxide and chloride. When we are electrolyzing the very dilute sodium chloride solution, then we just consider about ECS, and hydroxide has a higher position than chloride in ECS, so hydroxide will preferentially discharge. Up to now, it's common what we have learned. We look at ECS because hydroxide is a stronger reducing agent than chloride because we are not talking about the position, we are just talking about the ability. Okay, and for the half ionic equation, you can do it. And when electrolyzing concentrated sodium chloride solution, also we call it brine. Then, although hydroxide is a stronger reducing agent than chloride, the concentration of chloride is much higher than the hydroxide. Therefore, chloride will preferentially discharge, and you can do it for the half ionic equation. And the last factor besides ECS, concentration effects of only applies to iodide, bromide, and chloride ion. We also need to consider about the last factor, which is the material of the electrode. So usually it divided into two types of electrode. Okay, first of all, graphite and platinum, they are inert electrode. They will not react during the electrolysis. However, when you see electrode like mercury and copper or silver, then you have to pay attention. For mercury, because it's liquid, so usually we will use a tube for it. And if mercury is it's connected to the positive of the battery, it will not affect anything. But if the mercury, for example, dip into here, or here, okay, let me fix it. Okay, a wire dip into the bottom of the U-tube, this U-tube, not that U-tube, okay. And then this is mercury. Okay, I write it on another side. I'm afraid that you will misunderstand it. It's connected to the positive electrode of the battery. Okay, if it's connected to the negative electrode of the battery, that means the electron is coming out here. Then it will favor both hydrogen ion and sodium ion will be attracted, right? In normal case, according to ECS, it should be hydrogen ion discharge, right? The hydrogen ion will discharge. But when it comes to the case of mercury, because mercury loves metal, so instead sodium ion will discharge. This time not hydrogen, okay? Sodium will gain electron and form sodium metal. Okay, and another case is if if silver, copper, or any other kind of metal electrode is connected to positive of the electrolytic cell, for example, here is copper, silver, or magnesium, or zinc, or other metal, then these metal will, because they are reactive, they are not inert electrode, they are reactive electrode. So instead, copper will discharge and lose electron. So there are two more factors we have to consider besides ECS. One is concentration effect, and another is material of electrode. If it's mercury, if it's made of mercury, and if it's mercury and it's connected to negative, then it will, because it loves metal, then the metal ion will preferentially discharge. And if it's metal electrode and it's connected to positive, then because they are reactive, so they will preferentially discharge and lose electron. So what you need to do is complete the red marks, the question marked by red pen. 3, 4 here, and here consider about this, which is on page 11. Okay, on page 11, this setup using mercury as cathode. Okay, 5, 6, 7, okay, and 8. So you have to do these, and then for others you don't need to do it. Okay, up to here, 8, and also here. Okay, 9, 10. This table, it's using graphite electrode, so it's just a normal case that you have learned. So I'm not going to help you. I'm not going to give you any help. Try to do it by yourself, okay? And then also this, using and also this, but this one you have to apply what you have just learned. It's using copper electrode. Okay, so both of them are copper electrode, and the electrolyte is copper 2 sulfate solution. So what do you think about will happen on both electrodes? So try to think about it and then complete question 20, 21, 22, and 20. Yes, and that's all. Okay, so try to think try to deduce the product of these electrolytic cell according to the 3 factors. Number 1, ECS, and number 2, concentration effect, and number 3, lastly, the material of electrode, and deduce the product. It's very important of this chapter. You have to deduce the product as 2 electrodes. That means you have to know what's going on as the 2 electrodes by applying those 3 factors. Again, I repeat it: ECS, concentration effect, and material of electrode.